Section 14.6, applying sum and difference formulas. Now, it would be nice and dandy if we could just quick and easy just say, oh, just add this a and b and we want the sine of that. But sometimes we can't necessarily do that. So with the sum formulas, if we have the sine of two numbers added, then this is going to be the sine of a times the cosine of b plus the cosine of a times the sine of b. And the cosine is going to be, you're going to multiply the two cosines and then subtract the two sines. And I wrote this wrong. This should be sine in here. Ha ha. There we go. All right. Nothing like fixing it on the fly. All right. So, and then tangent is just a little bit different. You're going to add the tangent of a and b and divide by 1 minus the product of the tangent of a and the tangent of b. Now, if you'll look in your book, I believe on page 949, all of these are written out for you. So if you don't, if you're not clear about this, what I've done is a lot of times with the formulas, if I look to see, well, what's the similarities, it's easier for me to memorize them. So the difference formulas, instead of memorizing another whole set of formulas, the difference formulas are going to be exactly the same formulas, except all of the signs are exactly the opposite. So if you're subtracting sine of a minus b, then this is going to be sine a cosine b minus cosine a sine b. And if you're subtracting here, then you're going to add here. And if you're subtracting here, you're going to subtract here and add here. Now, if that was totally too confusing to you, then go to page 949 and copy those down. Otherwise, we're going to use this. Here we go. The first couple of problems I have, the first couple of examples, and the first set of your homework is going to say to evaluate exactly what is the sine of 7 pi over 12. Now, what I want you to do is I want you to use these formulas to come up with, well, okay, the sine of 7 pi over 12 is the same as the sine of pi over 3 plus pi over 4. So what you're going to do is you're going to take the either the degree measurement or the radian measurement, and you're going to divide it up into sections, into parts that you do know the answer to, and you're going to use, you know them by the cute little unit circle that I've given you that I'm sure you've memorized by now, right? All right, so in order to do this now we've got pi over 3 and pi over 4 are both on your unit circle, so you know the sine and cosine of both of those. But you can't just take them and add them together, all right? You've got to use your formula, so let's just plug it in. So the sine of, this is a sine function, so sine of a plus b is going to be sine of a, which is pi over 3, sine of a cosine b, which is pi over 4, and to that we're going to add, and now we're going to do the opposite. We're going to take the cosine of the first one and the sine of the second one. So cosine of pi over 3, sine of pi over 4. All right? Once you start seeing the similarities and see where the parts are coming from, then you can actually memorize these quite quickly. So then we're going to go to your handy dandy little circle. The sine of pi over 3 is square root of 3 over 2. Times the cosine of pi over 4 is square root of 2 over 2. And to that we're going to add the cosine of pi over 3 is 1/2. And the sine of pi over 4 is square root of 2 over 2. All right, so then when you multiply them out, nothing will cancel, so square root of 3 times the square root of 2 is the square root of 6 over 2 times 2 is 4. Plus, multiplying straight across is square root of 2 over 4. Oh, so I can just put the whole thing over 4. So plus the square root of 2 all over 4. And that is your final answer, because remember, you can't combine square roots that are different. All right? So square root of 6 plus square root of 2 all over 4 is your final answer. All right, well, what if we have cosine of 15 degrees, and so I look and I see, well, I've got 30 degrees, and I've got 45, and I've got 60. but I don't have 15. Well, can I just take half of 30? Well, you can, but not in this section. In a different section, we'll do that. So cosine of 15, well, you know 60 and you know 45. So you could take the cosine, let's do it in a different color simply because I'm running together here. Cosine of 60 minus 45, because 60 degrees minus 45 does give you the 15 degrees. So now you use your difference formula, and now if this is freaking you out, go back to your book. But I'm going to use the sum formula and just change that sign. All right. So we want the cosine of the two angles. So cosine of 60 times the cosine of 45, and then I'm going to add instead of subtract, and then I want the sine of each. So sine of 60 times the sine of 45. And now we know the sine and cosine of these angles, so go to your handy dandy little circle, find 60, and the cosine of 60 is 1/2, times the cosine of 45 is square root of 2 over 2, plus the sine of 60 is square root of 3 over 2, and the sine of 45 is square root of 2 over 2. And then you've got all the parts and pieces. Simplify it. That's all you need to do. And actually, this is looking very similar to this, isn't it? So you've got square root of 2 over 4 plus square root of 3 times square root of 2 is square root of 6 over 4. So this final answer is also square root of 6 plus square root of 2 all over 4. And if you had left it square root of 2 plus square root of 6, that's the same thing. It's fine. All right. So the trick with that is to break up your angle, either the radians or the degrees, into sections that you do know, 30, 60, 30 degrees, 60, 30, 60, 90, or 45. All right? Okay, so now if I give you, I want to know what is the tangent of A minus B. For tangent of A is negative 7/24 and tangent of B is 4/5. So what I want you to do is just use this formula and fill in the parts. I'm giving you the tangent of these two angles. So you're going to use the formula. This is a difference formula, and I've given you the sum, but I've said the difference is just the opposite signs. So what you're going to do is you're going to say tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B. So plug in the pieces. You can look at the formula here. Tangent of A is negative 7/24 plus tangent of B, which we said is 4/5. And that's all over. So we're going to end up with a compound fraction, but you can so do that. And then 1, and guess what? I did it. This is subtraction, and so this needs to be the opposite sign. And you're saying, whoa, you said. This is the difference formula, so this needs to be minus, and this one is going to be plus. All right? So that's the only trick with not writing it down twice. All right, tangent of A is negative 7/24, and tangent of B is 4/5, and you're multiplying those. All right, so now you just simplify it. Now it's just really simple algebra stuff. All right, so if we're subtracting these, and actually they're both negative, so we're going to add, but we need like denominators. So the like denominator is going to be 120. So we're going to take 24 times 5 to get 120. So 7 times 5 is negative 35. 5 times 24 was 120. So 4 times 24 is 96. And you can continue on and simplify the numerator. Negative 35 minus 96, you're going to add them and get negative 131 over 120. Your denominator, you don't have to get like denominators yet. Let's multiply these, and when we do that, we can reduce beforehand, and nothing else will reduce. So we've got 1 plus, we've got negative 7. Actually, let's make it 1 minus since it's a negative 7. 1 minus 7 over 6 times 5 is 30. So then 30 over 30 minus 7 30ths, is that going to be 23 30ths? 30 minus 7 is 23, yes. So now you just have a fraction over a fraction, flip and multiply. So you're going to flip this one and say 30 over 23 and this will reduce, and this will reduce. So now we just have negative 131 on the top, and 23 times 4 is 92. So negative 131 over 92. All right, so you have the formula. This really and truly is just plug in the numbers to the formula. Easy sneezy. All right, 2 more. Here we go. On these, what I'm asking you to do is simplify. Just simplify it. You won't be able to get down to a final answer because you have an x. So once again, we're going to have to be careful because I didn't write out the difference formulas, but you're simply going to use your formula. So the difference formula for sine is you do a sine and a cosine, and then a cosine and a sine. So we're going to do sine of x cosine of 5 pi over 2. And then because we're doing the difference, we're going to subtract and say cosine of x sine of 5 pi over 2. Do you see where I get the parts? Once you get this, use your handy dandy little circle to say that 5 pi over 2, and you're going to say, but 5 pi over 2 isn't on here. Well, let's look. Over 2, those are the halves. So halfway, there's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. 5 pi over 2 is straight up and down again. All right, so there's 1/4, 2/4, 3/4, 4/4. 5/4 is the same as pi over 2, and the cosine of that is 0. So we have sine of x times 0 minus cosine of x times, the sine here is 1, times 1. So if you take this times 0, it goes away, and this times 1, negative cosine of x is your final answer. Easy sneezy. Last one. What we're going to do now, so this is just simplifying. This is when we don't have, it's not an equation. There's not something that it's equal to. We can't set it, we can't find the answer to x. Remember I said you're not going to find an answer. Well, on these, if I set it equal to something and I say now I want you to solve it, well, now what we're going to do is, oh, looky there. That should be here. Okay, that's okay. So now what we're going to do is we're going to solve this. We're going to use the formulas that we have, and then we've got it set equal to 0, so we can go back and forth and find out what x is. So let's use our formulas. We're going to use a sum formula, and this is the cosine. So for the cosines, you do cosines first, subtract the sines. So cosines of both of these, cosine of x, cosine of pi. And then we're going to do, and this is a sum, so we're going to do minus the sines. Sine of x, sine of pi. Now this gets tricky because we're adding, okay, so all of this is this part. Now we're adding this part. We can do that. Cosine of x minus pi. So now we're going to do the difference formula. So we're going to do the same thing, cosines and then sines, but now we're going to add in between. So we're going to do cosine of x, cosine of pi, and we're going to add in between instead of subtracting, and now we're going to do the sines. Sine of x, sine of pi, and I'm glad it equals 0 and not some long crazy thing. All right, so now use your handy dandy little circle, and you know cosine at pi is -1. So cosine of x times -1 is negative cosine of x. Minus sine of x times sine of pi. The sine at pi is 0. So that just totally drops out. Minus 0. You can even put in minus 0 if you wish. Plus cosine of x times cosine of pi. Cosine of pi, remember, is -1. So now this is minus cosine of x. Plus sine of x, sine of pi. Well, we just said sine of pi was 0. So that's gone. We could say plus 0 if you wish, and that equals 0. Now when you combine like terms, we have -2 cosine of x equals 0. Divide by -2. I don't know how far I can go before you can't see. Cosine of x equals 0. So now you simply go to, what you're going to do now is, this is cosine, you want the inverse cosine of 0. Which simply means, well, you look on your circle and you say, where is cosine 0? And I can say, oh, it's right here at pi over 2, and it's right here at 3 pi over 2. So x is either pi over 2 or 3 pi over 2. There's your two answers, and you're done. All right? No problem. You got this. So really and truly, this is a lot more just algebra stuff than trying to figure the trig functions, except that you've got your unit circle. So anytime you have a trig function, just look on your unit circle and figure it out. Don't forget your pluses and minuses for the differences. If you need to write that out, feel free to do that. Good luck. See you soon.